This is Embedded Systems' first lab, which is the flashlight. And this is Jamie Keller.
And Jeremiah Williams.
And so first we'll go through the code. So for our code, we started with defining a few variables, and then we went to setting them as inputs and outputs. And then we made like everything binary with these two lines. Then from there we went to our button loop, which sets 1 bit in port D to turn on at the beginning and then off down here at the end. So that way we can use the oscilloscope to measure like how long our loop takes. And then from there we incremented the random variable. And then we also took that modulus 8 and set that value equal to, or random variable equal to that value. So then we go to the buttons. So this one is RB0, which then displays turns on all of the ports so that it makes the light not turn on anything. And then from there we just do like RB1 is the next line, and that turns on red, and then RB2 turns on green, and then RB3 is blue, RB4 is white, and then the last one is random. And then to do the random, we just called the random val or rand val to be displayed for that value. And then we turn off our bit at the end, and then our loop is done, and that's our code.
Nice. All right. Ready. Okay, so then here we've got the hardware. Underneath this little lamp of paper, we've got the RGB LED, and then it has a common 5 volts over here that's connected to all the little LEDs in there. And this one, a little bit weirder one, is 120 ohms, goes to the red just because it has a little bit lower current, or a little bit lower voltage drop than the other two, which we've got connected to 82 ohms here. And then they all go into pins on the microcontroller. So as you can see right now, we've got them in all off because there's 5 volts here, 5 volts there, no voltage differential. Then when we hit RB1, drops that to ground, gets voltage across the red, hits that, drops that bit to ground, gets voltage across the green. Next button, drops the last bit, gets voltage across blue. 4 here, drops them all, so we've got voltage across all of them equally, looks white. And then our random one here can get all sorts of colors and all sorts of numbers over there, all mod 8. And then RB0 puts them all high again and turns them all off.
I forgot to mention there are 36 lines of assembly code, so that's how long it took for us to do the project. And then also up here is our oscilloscope reading, and it takes 4 grid squares at 500 nanoseconds per grid, so then that would be 2,000 nanoseconds that it takes. And then this is where we have our oscilloscope connections hooked up. So we have the one wire going into that bit that we turn on and off, and then it's just also connected to ground.
So here we've got the multimeter in series with the red one, and we can see up there that it's getting right about the 20 milliamps we want. And then we'll move this little guy over so it's in series with the green one, and we're getting pretty close. Again, 19 milliamps within our acceptable 5 milliamp range. Finally, the blue one drawing just under 18 milliamps again, still within our range of 5 milliamps above or below 20 milliamps.